Hi, I'm Nikki Kringos, Associate Professor, Highway and Railway Engineering here at KTH. In this lecture I'm going to talk about fundamental material science and multi-scale modeling and how it can bring innovation in pavement engineering. Now let's go to the past. Here we are at an ancient road. So we talk about innovation and that's in the future, but let's go back and see what they did in the past. In fact, the structures that they built the roads up, even in the Roman Empire, are not that unlike what we do today. Now let's go to modern times. So this is the kind of road which we're more familiar with, right? Traffic everywhere, the nice black surfacing of the asphalt. So that already looks very different from the Roman road, right? But structurally there are not that many differences. One thing that is rather different is the material. So we can look today much more closer at the material. So rather than talking about it, let's do it. So here you can actually see a core of asphalt which we can take out and we can now take to the lab to analyze further. So once we have these specimens in the lab, there's many different things we can do with them. We can test the mechanical properties, we can analyze the chemistry of the individual components as well as the mixture. We can put these two together, so understanding how chemistry affects the mechanical properties. We can also analyze damage, how cracks form, how actually the rutting in pavement happens and how potholes form. And by doing that, we start understanding how the material behaves, why it behaves this way, and we can start improving on the materials that we use today. But we can start also developing new materials for the future. Let me show you first on how we're actually making these computer models.